a nanoscopic solution to a colossal problem.
Here you can see a thriving coral reef full of active life and color. And here is a coral reef today, dead due to the effects of ocean acidification.
Ocean acidification is one of the most prevalent issues in today's world. It is responsible for the deaths of coral reefs across the world, as well as being a leading cause of climate change.
As you can see in this graph, the trend for pH levels in the ocean has dropped significantly in the recent years. The Smithsonian, one of the world's largest research complexes, said that in the past 200 years alone, ocean water has become 30% more acidic, faster than any other change in ocean chemistry in the last 50 million years.
Ocean acidification happens when CO2 from factories and cars is absorbed by the ocean. The CO2 mixes with H2O and carbonate ions to create two bicarbonate ions, which impedes calcification.
Our solution is a cyanobacteria as a means of absorbing the excess carbon dioxide in the atmosphere.
Cyanobacteria comes with an abundance of other benefits, such as reducing atmospheric CO2, which would help combat climate change, decomposing organic waste, creating isobutanol, a naturally occurring oil substitute in many uses, and also supplying needed nitrogen to coral reefs.
Cyanobacteria do come with some drawbacks. If it were to spread too fast, it can create dead zones in the oceans, which are toxic for fish and people.
A possible solution could be to develop a thin, buoyant material that can sustain large populations of algae while allowing water to diffuse through. Another implementation would include genetically modifying the algae to fixate CO2 quickly and to deposit that CO2 quickly without dissolving it into the ocean.
Companies have developed similar ideas in the past, however, none of which have been implemented due to mass oil companies making money. This solution is feasible and sustainable with the potential to become a mass source of energy while reducing the acidity of the ocean. The semi-permeable membrane is challenging to perfect and must be effective and trustworthy enough to not let the algae overtake the ocean. In the beginning stages, ships with nets will implement the algae, dragging it through to avoid storms. This will also boost the economy by creating jobs and producing energy. Membranes will be implemented in the future.